Welcome, my dear student. As in the last video, we discussed about interrupt, and in the similar that same no, parameter and the same term, we'll try to discuss in this video also regarding to the interrupts and all. When the processor receives an interrupt request, it must branch to the interrupt service routine. It must also inform to the device that it has to be recognized for the interrupt request. And this can be accomplished by the two different way. Some processor have an explicit interrupt acknowledgement control signals for this purpose. In other cases, the data transfer that takes place between the device and a processor can be used to inform the particular device. A return from the interrupt instruction at the end of the interrupt service routine, which reload the program counter from the temporary storage location, causing execution to be resumed with a certain load. The return address is to be saved in the processor stack. Alternately, it can be saved in a particular special location. As a part of an handling interrupt, the processor must inform the device that its request has been recognized so that it can remove the interrupt request signals, typically a special control signal on the bus. A common alternative is to have the transfer of the data between processor and IO devices interface to accomplish the same purpose. The execution of an instruction in the interrupt service routine that access of the status or the data register in the device interface implies to device that its interrupt request has been recognized. An important difference between an interrupt service routines and subroutine is that subroutine perform the function which is required by the program from which it is called, whereas the interrupt service routine may have nothing to in common with the program which being executed at the time that interrupt request to be received. The interrupt request interrupt execution of a program and may alter the intent sequence of an event. Sometimes such alteration may be undesirable and must not be allowed. For example, the processor may not want to be interrupted by the same devices by while executing its interrupt service routine. And the processor generally provide the ability to enable and disable the such interruptions as desired. The one simple way is to provide a machine instruction such as interrupt enable and the interrupt disable for the purpose. To avoid the interruption by the same device during the execution, an interrupt service routine have the two different parts. That the first instruction of interrupt service routines can be interrupt disable, and the last instruction of the interrupt service routine can be interrupt enable. Right? So this is the particular way. The information, in fact, the two programs often belonging to the different users. And before starting the interrupt service routine, any information that may be altered during the executions of the of that particular routine must be saved. This information must be restored before execution of the interrupt program to be resumed. The information that must be saved and restored typically, which include the condition code flags and the content of the any register which is used by both interrupt program and interrupt service routine. The task of saving and restoring the information can be done automatically by the processor and by program instruction. The most of the modern processor save only the minimum amount of information which is needed to be maintain the integrity of the program execution. And this is because the processor of a saving and restoring the register which involve the memory transfer that increase the total execution time and hence the represent execution overhead. The saving register also increase the delay between the time and the interrupt request is received and the start of the execution of the interrupt service routine. This delay which is called as the interrupt latency also. In some of the applications, the long interrupt latency is unacceptable. Multiple IO devices may be connected to the processor and the memory via bus. The sum of all of these devices may be capable of generating the interrupt request also. Each device operate independently, and hence the no definite order can be imposed on how the device generate the interrupt request. How does the processor know which device is to be generated an interrupt? How does the processor knows which interrupt service needs to be executed? And when the processor is executing an interrupt service routine for one device, can other device interrupt the processor? If the two interrupt requests are to be received simultaneously, then how to break the tie? So these are the certain things. We will try to see each and every condition. Typically, the processor saves only the content of the program counter and the processor status register. Any additional information to be saved must be saved in the program instruction at beginning of the interrupt service routine and restored at the end of the routine. Okay. Now, in some of the early processor, particularly those with a small number of registers, all the registers are to be saved automatically by the processor hardware, and the data saved are to be restored to their respective register as a part of the execution of the return from the interrupt instruction. To minimize the interrupt overhead, some computers provide the two types of interrupt. One save all the register content and other does not. Particularly IO devices may use either type depending on its response time requirement. Another interesting approach is to provide the duplicate set of the processor register. In this case, the different set of register can be used by the interrupt service routine, thus eliminating the need to save and restore the register. And interrupt is more than the simple mechanism for conditioning for coordinating the IO transfer. In general, interrupt enable the transfer of the control from one program to the another program to be initiated by an event which is outside the computer, and the execution of the interrupted program resume after the execution of the interrupt service routine is to be completed. And interrupt handling is the important function in operating system. Interrupt are also used in a mini control applications in which the processing of certain routines must be accurately timed and relative to the external event. This type of application is to be referred as the real-time processing. We can also call it the real-time processing also. Consider the simple arrangement where all the devices send their interrupt request over a single control lines in the bus. And when the processor receives an interrupt request over this control line, how does it know which device is requesting an interrupt? This information is available in the status register of the device requesting an interrupt. This status register of each device has an IRQ bit, that is interrupt request bit, which is set to 1 when it requests to enter. If it not requested, then it is to be 0. But if when it is to be set, it means that when it is to be requested. The interrupt service routine can pull the input output devices connected to the bus. The first device with IRQ which is equal to 1 is the one that service. And the polling mechanism is easy but time consuming to query the status bit of all IO devices connected to the bus. Now there are again some different portion and different important things, that is how to enable and how to disable that interrupts and all that we have to discuss in the next video. So keep watching that video and thank you.